I trust you found part two to be a lot quicker and simpler than part one. Yes, we did. Give us more like that. Well, I can't promise that. But okay, part two. The trick for those of you who have memory issues. I personally have memory issues, as I've told you many times before. For those with memory problems, just remember this, the trick. You're either going to multiply, to convert from degrees to radians or radians to degrees. You're either going to multiply by pi over 180 or by 180 over pi. I can never remember which one to use. Okay, well, which one makes sense in the given circumstances? Which one will give you the desired result? Let's take a look at it. For number 2, do we multiply by that or by that? Those are your only choices. 210 degrees. Well, we're going from degrees to radians. Our answer needs to end up with a pi in it. But would it make sense to have a pi in the denominator? No. We want to have the pi end up in the numerator. So we're going to multiply by pi over 180. Then we simply reduce 210 over 180, or reduce 21 over 18. Divide them both by 3, we get 7 sixths. 7 sixths pi. Done. Number 4. Again, we want to insert a pi into this to make it into radians. By the way, radians don't have to have a pi in them, but in the context of what we're doing, they always will. So to change this into radians, we want to multiply by pi over 180, so we end up with a pi in the numerator. We certainly don't want to have a pi in the denominator. That's what this would do to us. We want to end up with pi in the numerator, of course. So we just reduce our fraction, and 15 over 180 happens to be exactly 1 over 12, so our result is pi over 12, just reducing our fraction. Done. Changing from radians to degrees, again, you ask yourself, which one do I multiply by? Well, going to degrees, I want the pi to disappear. Would this make pi disappear? No, I would end up with pi squared. Whoa! No, we're going to multiply by this guy. So multiply by 180 over pi. The pi's cancel, yay! And 180 divided by 3 gives us 60. So we have 60 times 2. We have 120 degrees. Done. Negative 3 pi over 2, same thing again. We want to multiply by the choice that's going to make the pi cancel out. We want to have a pi in the denominator. Therefore, we'll multiply by 180 over pi. Again, the pi's cancel. 180 divided by 2 being 90. 90 times negative 3 will be negative 270 degrees. We're done. Hey, don't forget on the unit circle how to find negative 270. Positive angles go this way. Negative angles go that way. So negative 270 would take you around to here. Whoops, sorry about that. Negative 270 takes you to there. It's the same thing as 90. Negative 270, positive 90. All right, that brings us to number 10. Somewhat slightly more difficult concept here. Where we need to first of all find what is the cosine of pi over 3, and don't use the calculator. Yes, you can punch your buttons. Cosine of pi over 3, it's going to give you some decimal approximation. No, we don't want a decimal approximation. We want to skip the calculator and go with the unit circle concept. We can do this. Where is pi over 3? Of course, that's the key question in number 97. Where are these angles? Pi over 3, hopefully you remember, there's a trick to remember where pi over 3 is. Pi over 3 goes there, while pi over 6 goes here. This is 30 degrees, this is 60 degrees. Remember the trick? This is 30 degrees, this is 60 degrees. Notice that the pi over 6 goes with the 30, and the 3 goes with the 60. They are reversed. The over 6 goes with 30 degrees, and the over 3 goes with 60 degrees. That makes it easy to remember. Not only that, but as we'll see when we look at number 97, it makes sense too. All right, this is, again, 60 degrees. You know how that works. We have a hypotenuse of 1 because we're talking unit circle here. The short leg is going to be half the hypotenuse, and the long leg is the short leg times square root of 3. So what's that thing doing there? Let me see if I can delete that. It's in the way right now. Yes, I can delete it. Gone. Okay. So multiply by square root of 3, and this becomes 1/2 times square root of 3, better known as square root of 3 over 2. You are, by the way, responsible to know how a 30-60 triangle works. If the hypotenuse is 1, the short leg is 1/2. By the way, do you remember why that's true? Because a 30-60 triangle is exactly half of an equilateral triangle. If it's exactly half of an equilateral triangle, that would have to be 1, therefore this has to be 1/2. And the Pythagorean theorem will then tell you that this ends up being square root of 3 divided by 2. So anyway, there we have that one. So let's find the cosine, and we refer back to our friend SOHCAHTOA. By the way, there is the other way to do it, of course. We can find the coordinates of this point with great ease, correct? The coordinates of that point would be 1/2 square root of 3 over 2. And do you remember the old definition of cosine? The old definition of cosine is, it's the first coordinate. Sine is the second coordinate, cosine is the first coordinate. Well, let's use SOHCAHTOA to get the same result. SOHCAHTOA says cosine is adjacent divided by hypotenuse. Adjacent, 1/2, divided by hypotenuse, 1. 1/2 divided by 1 is 1/2. Plus. Now, sine of pi over 2. How do you do pi over 2? Well, this is 0. This is pi. Well, what's halfway between 0 and 1 pi? It would be 1/2 pi. We're talking 90 degrees. So to help us visualize that, we kind of draw a little super skinny triangle here. How skinny should that triangle really be? Well, it should be so skinny that it doesn't exist. So really, this adjacent side has a length of what? It's actually a length of 0. The hypotenuse is 1, and the long leg is 1. So now we apply SOHCAHTOA. SOHCAHTOA, we're looking for sine, that's opposite over hypotenuse. That's opposite over hypotenuse, that's 1. So our answer is 1/2 plus 1, better known as 3/2. So number 10, your result is 3/2, 3 over 2. We move on to number 12. This time they gave us degrees. How nice. We're much more comfortable with degrees than we are with radians, aren't we? But we're getting better with the radians. I mean, you should very quickly recognize pi over 3 as being 60 degrees. Ooh, same as this one. All right, so 60 degrees we located here. We realize, oh, I have another 60, 30 triangle, so I know if the hypotenuse is 1, the short leg is 1/2, the long leg is square root of 3 over 2. Same thing we saw just moments ago. So the cosine of 60, adjacent over hypotenuse, 1/2 over 1. That's 1/2. But don't forget to multiply it by 4. So here we have 2. Plus. Okay, 3 times the tangent of pi over 3. Oh, well, pi over 3 is the same thing as 60 as we already observed. That's 1/3 pi, 2/3 pi, 3/3 pi, 3/3 pi. Makes sense. Counting by thirds, we realize, oh, I'm at 1/3 of a pi. 1/3 of a pi would be right here at what we call 60 degrees again. So we want tangent, tangent being opposite over adjacent. That's square root of 3 over 1/2. That's square root of 3 times Precalc 2, better known as 2 square root of 3. But we have 2 square root of 3, and we still have to multiply by 3. So that gives us 3 times 2 square root of 3, which is 6 square root of 3. And unless I did something silly, that should be our final result. It is 2 plus 3. Wait a minute, I did do something silly. What did I do wrong? I divided, oh yes, I very, very carelessly just wrote square root of 3 here. The opposite side is square root of 3 over 2. Scratch that. Square root of 3 over 2 divided by 1/2. Sorry about that. I'm sure somebody caught that before I did. We multiply by the reciprocal of 2. The 2's cancel, so this equals square root of 3. But I don't have just square root of 3. I have square root of 3 times 3. So my final answer is 2 plus 3 square root of 3. 2 plus 3 square root of 3. We're now, for real, done. And now we move on to 14. 2 pi, we get to practice once again. How do you find these angles? This is a multiple of 1/3 pi. It happens to be 2/3 pi. We all have a lot of experience now from the previous screen in finding 1/3 pi. So if this is 1/3 pi, 2/3 pi's could put this over here. Just like 3/3 pi would put us back here. Yeah, this would be 3/3 pi, better known as pi. So this is 2/3 pi. 1/3, 2/3, 3/3. We're right here. This is, again, 60 degrees. They're using a lot of 60-degree angles in these problems. So we want the sine of 2 pi over 3. This, of course, is negative 1/2 and positive square root of 3 over 2. Sine is opposite over hypotenuse. So this is square root of 3 over 2 over 1. Who cares? But we multiply it by 3. So there we have 3 times the sine of 2 pi over 3. Minus. Now I've got to locate 5 pi over 2. Well, I've already got it marked here. How do I find that? Well, count by half pi's. That's 0. We know that's 1 pi. So this is 1/2 pi. Now count by 1/2 pi's. 1/2, 2 halves, 3 halves, 4 halves, 5 halves. There's 5 halves pi. Yes, there are other ways we could have looked at that. We could have subtracted out a 2 pi. We could have subtracted out of this a 2 pi or a 4 halves pi. Why? Because these angles repeat themselves every 2 pi. Every 360 degrees they repeat themselves. So I can subtract out 2 pi. Well, 5 pi over 2 minus 2 pi gives me 1 pi over 2. 1 pi over 2. And you say, oh, I know what that one is. That's 90 degrees. We're talking 90 degrees. Any way you look at it, it's right there. So we draw our little imaginary pretend triangle here, where the adjacent side here is actually supposed to be 0. Hypotenuse being 1, long leg being 1. And so we're looking for cosine. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Oh, that's going to be 0 over 1. That's going to be 0. Times 4 is still 0, so that all goes away. My final answer is just 3 square root of 3 over 2. Done. And now we move on to the review of how to find these angles. Well, I've got them all marked here for you, but let's talk them through anyway. And then we'll practice on another circle that doesn't have the radians. All right? So, again, it would behoove you simply to remember that 30 degrees and 60 degrees, 30 degrees and 60 degrees, 30 goes with pi over 6, 60 goes with pi over 3. Or, simply look at it this way, we know that this is 0 pi, this is 1 pi, divided into thirds, and we have, therefore, 1/3 pi, and we have, right here, 2/3 pi, and then we have 3/3 pi, otherwise known as just pi. Count by thirds. Well, what's halfway between 1/3 pi and 1/6 pi? I'm sorry, I didn't mean that. What's halfway between 1/3 pi and 0? Between 1/3 pi and 0, half of 1/3 pi, half of 1/3 pi is going to be 1/6 pi. And then for this guy, who's at the old familiar location of 45 degrees, well, what's halfway between 0 and a half pi? Halfway between a 0 and a half pi would be a 1/4 pi. Once you get these three guys, which it's better to just memorize those rather than having to think them through every time, but yes, you can think them through. They do make sense. As long as you know this is 0 and that's 1 pi, these you can figure out if you have to. But why figure them out if you can just memorize these three? That's really all you need. Once you have pi over 6, we can start counting by sixths. 1/6, 2/6, 2/6 is 1/3, 2/6, 3/6, 3/6 is 1/2, 4/6, reduce 4/6, you get 2/3, 5/6, can't reduce that, and 6/6, better known as 1 pi. And then keep counting. From 6/6 we have 7/6. Then go down again another 30 degrees. Oops. Go down another 30 degrees. We have 7/6. We have 8/6. 8/6 reducing to 4/3. Then we have 9/6. Well, 9/6 reduces to 3/2. Then we have 10/6, which reduces to 5/3. We have 11/6, and then we finally have 12/6. Comes right around, makes sense. 12/6 equals 2 pi. So count by sixths. You can get them all. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6. It makes sense. We can count by 30 degree, I'm sorry, that was counting by 30-degree angles. We can count by 60-degree angles. This is 1/3. There we have 2/3. Here we have 3/3, or just pi. Then we have, that's 3/3, we have, oh yeah, I just lost there for a second. From 3/3 we have 4/3. Then we have 5/3. And then we have 6/3. 6/3 pi, better known as 2 pi. Or we can count by 45-degree angles. 45 degrees being 1/4. We have 1/4. 2/4, better known as 1/2. 3/4. 4/4 pi, better known as 1 pi. 5/4, 6/4, better known as 3/2 pi. 7/4, and 8/4, better known as 2 pi. So once you have these three guys in your head, or once you can figure them out and get them in your head at on the spur of the moment, better to just know them, then all the others fall into place by counting by sixths, or counting by thirds, or counting by fourths. This guy's not even worth memorizing because you know it's half of 1 pi. Okay, so there we have it. Do I have, yes, I wanted to practice with you one more time because finding these angles is critical, as you know. So, one more time. 30 degrees is, and we're just going to assume that you're going to memorize this, you already know it. Don't use the 3, use the 6. Don't use the 6, use a 3. This is pi over 6. This guy is pi over 3. Oh, let's go full screen here. 45 degrees is going to be half of pi over 2, so it's going to be pi over 4. From there, we just count. Let's count by sixths. 1/6, 2/6, 1/3. 3/6, 1/2. 4/6, but 4/6 reduces to 2/3. 2/3 pi. That's 4/6. 5/6. 6/6, but 6/6 is just 1 pi. We already knew that. Then we have 7/6. Then we have 8/6. Reduce that to 4/3. 8/6, 9/6, which reduces to 3/2. Here we have 10/6, which reduces to 5/3. 11/6. And then we know we did it right because we come right back to 1 more sixth gives us 12/6, which we know has a better name of just 2 pi. And we say, hey, I ended up in the right place. Yes, you did. Then for the 45s, we have 45 being 1/4, then 2/4, then, we haven't done this one yet, 3/4 pi, then 4/4, and then 5/4 pi, 5/4 pi, then 6/4, and 7/4, and then finally 8/4 pi, and it's reassuring to know that we did indeed come right back to where we belong at 2 pi. It all works perfectly. You can do this. All right, that's it for the review. I'm planning on having a Zoom session probably next Wednesday during our regularly scheduled pre-calculus times. We don't conflict with any other classes. And when is that? I have no idea because I never need to know. There it is. We are normally scheduled for 12 to 12:45. So at 12 o'clock on Wednesday, planning on a Zoom review session due to popular demand of at least one person. I guess that doesn't exactly make it popular, but that's all right. We'll still do it anyway. All right. See you then. I mean, for real, see you then. That'll be cool.